This is the third worked example on writing classes. So far, we've looked at the subgoal labels to name the class, define all of the instance and class level variables, and creating constructors. In this worked example, we will look at creating the accessors and mutators. The subgoal for this is to create one accessor or getter and one mutator or setter per attribute. For the accessors, you need to remember the name is usually get followed by the attribute name. They're always public. They need to return the same data type, that is the attribute's data type. They usually have no parameters, and the logic itself is just to return the value of the instance attribute. For the mutators, the name is generally set followed by the attribute name. They're public, the return type is usually void, and the parameter takes in one parameter that is the same data type as the attribute. The logic of the method should validate the input parameter and then set the attribute value. Let's look at our example. Again, we're representing a class to represent an instance of time. We have declared the attributes. Now we want to write the appropriate accessors and mutators. Subgoal 7 says to create one accessor and one mutator per attribute. We have 3 instance attributes, hour, minute, and second, so we will need 3 getters and 3 setters. To create the first getter, we will look at getHour. We name the method getHR. Notice the camel case so that we can distinguish between the get and the attribute that we're getting. It is public. The data type that we want to return is the same data type as the instance attribute. We declared hour as an int, so this method will return an int. There are no parameters for getters, and the logic is simply to return the value of the instance attribute, hour. Here we've created our other two for getMin and getSec. Again, the name always is get followed by some version of the attribute name. They're both public. The return type is the same data type as the attribute. Both minute and second are integers, so these methods also return ints. They have no parameters, and the logic is to simply return the value of the instance attribute. Subgoal 7b is to create the mutator. In this case, we want to call it set something. We will call it set HR, again in camel case. The method is public, the return type is void, and the parameter is the same data type as the attribute. Since hour is an int, we want to take in one integer parameter called HR as a parameter to this method. The logic of this method needs to validate the value in the input parameter and then set the attribute value to that if it is legal. In this example, we want to validate that HR is between 0 and 23 inclusive, and then assign HR to our instance attribute hour. Here are the other two mutators, setMin and setSec. Notice that they are all public. The names are set followed by some version of the attribute name. The return types are void. They each take one parameter, which is the same data type as the instance attribute. Since minute and second are both ints, these methods both take one integer parameter. The logic of the methods validate the input parameter before assigning it to the instance attribute. For both of these methods, we want to validate that the input parameter is between 0 and 59 inclusive before assigning it to its respective instance attribute. This is what our UML diagram looks like now. In the third section of the box, you will see that we have added the 3 getters and the 3 setters. Notice that they are all public, the parameter data types are given, and the return data types are given. Now that we've created these methods, we can now change our logic to the overloaded constructor. Remember, we had that same validation logic in the overloaded constructor. Rather than having the logic in the same place twice, we can now update the overloaded constructor to just call those setter methods. So instead of doing the individual validation in the overloaded constructor, we can just call setHour, setMin, and setSec with the appropriate parameters. Now that we've written these methods, let's see how they might be used in a driver program. We create one instance of the timeType class called Now, calling the default constructor. This will initialize it to have hour, minute, and second all to have a value of 0. That was the logic in our default constructor. We can now call the set methods to set the hour to 14, which would be 2 p.m., set the minute to be 30, and set the second to be 45, indicating that now it is 2:30 and 45 seconds in the afternoon. If we wanted to retrieve those values, we would just call the getter methods. That is the end of this worked example.